Regression, three methods. While we were talking about classification, we talked about three different approaches that you can follow in order to classify any data. That is, if you have a classification problem, how can you approach this? We had discussed about three different methods, in which the first method was to first find the class conditional density, and from that find the posterior, and then use decision theory in order to find the class C1, C2, C3, etc. And the second method was to directly find the posterior, and from that use decision theory to find out the class. And the third method was to directly identify a function f of x. This f of x would directly give you class C1, C2, C3, etc. So these were the three methods that we discussed in case of classification. And in classification, we also discussed about the merits, demerits, and all about these three different methods. So in case of regression, parallel to these three, we have three different approaches that we can choose in order to solve any regression problem. So let's see what are the possible options. So in case of regression, x is your input, right? T is the target that you want to find, and y of x is your regression function. In the previous, the lecture just before, we had seen that the value of y of x should be expectation of t given x in order to minimize the expected loss. That is, if we want to find the ideal regression function which would minimize the expected loss, then the value of y of x would be expectation of t given x. This is what we had seen in the previous lecture. So ultimately we are going to reach the point where we have to identify expectation of t given x. So in the first method, how do we do that? So in the first method, similar to what we did in classification, there we found the class conditional densities, then the posterior, and then the final class through decision theory. So the same thing if you do here, the first inference problem, what will it be? To find the joint density P of xt is what you want to find first. And once you have the joint density, from that you can find probability of t given x. So you want to normalize it to find probability of t given x, which is the conditional density. And once you find this conditional density, from the conditional density you can find conditional mean, which is expectation of t given x. Mean means expectation only. Expectation of t given x. So this is the final value of y of x that you want to find. So the first approach is following three steps, in which first you find the joint density P of xt, which is the joint distribution, and then P of t given x, which is the conditional density, and from this distribution you have to find the expectation of t given x, which is your y of x. And in the second approach, so finally your aim is to reach y of x equal to, you want to find it as the expectation of t given x. So reaching the first method is this. The second method, so you should be able to relate this exactly with the methods that we used in classification. I'm not explaining because whatever we explained there, everything is applicable as it is in this case also. So it will be a repetition of everything. And the second method is to first directly solve for your inference problem would be directly finding conditional density, which is P of t given x. And once you directly find P of t given x, you can marginalize this to find conditional mean, that is expectation of t given x. Once you find this expectation, this is your y of x. So this is the second approach, where you first find the conditional density, and from the conditional density you find the conditional mean, that is expectation of t given x. This is the second approach. And the third approach, same as we did in the classification problem. Third approach is directly finding a regression function. Though we found a classification function, simply in the same manner finding a regression function. So from training data, you would train the model to find a y of x, which will directly give you the final output, that is the regression function. So the relative merits, demerits, all things go hand in hand in case of classification and regression. So when we were discussing about classification, we did discuss it in depth about all the merits, demerits of each of the approaches. So all those things hold here as well. So you can refer to those lectures in order to find those details.